pi bullet docs. They said that for the humanoid especially, they tried to make it a bit more challenging. I'm not sure why.
Really?
Yeah, but I'm not sure if that's a general sort of methodology the pi bullet implementations took to be more challenging or more. I'm not
Yeah,
sure what.
yeah. We should really take a look because I feel like a lot of Pi Bullet's environment are not very well documented. Like, where did you find the documentation for its gym environments?
So everything that I've found is either by searching through implementations or through this doc. Let me share this.
Is that a Google Doc?
Yeah, exactly.
Yeah, I remember
Yeah,
that. It's such a strange thing that they're putting everything in a Google Doc, but
yeah. Even the Majoko Pi isn't super well documented, unfortunately, it's kind of required you to learn from just trying it out and checking out what the action space looks like, what the state space looks like. It's
right.
hard to figure it out just by looking at some docs.
hmm I'm actually looking at it right now. Let me take a brief look.
Yeah, so on page 61, they show the five
Uh huh.
environments that are ported from RoboSchool.
Uh huh.
And it says here at the very top, actually, yeah, the RoboSchool environments are harder than the Majoko environments. And I
Really?
guess these are ported from the RoboSchool to Pi Bullet. So that's probably why they're more challenging than just using Majoko Pi from the um, AI Majoko Pi environments.
I see. I see. But yeah, I would say like the Google Docs by itself, it's not very documented. Like for example, it doesn't tell you the action space, it doesn't give you the reward definition. It just feels like a lot of things are lacking, you know?
Yeah, I feel the same way. And for the OpenAI environments, they have this wiki page that
Uh-huh.
doesn't seem to be frequently updated, but it does help a little bit, especially for those things.
I see.
When they taste this here,
Mhm.
this helped me a little bit, at least just getting a quick look at which one are discrete environments, which ones are
Mhm.
continuous environments, what the reward range is, and so on. But
Right.
if you just search for the environments on the gym docs page, you won't really find that info directly there.
I will or I will not.
You'll not, yeah. So you search,
Yeah,
they show
that's
you
my
a
point.
rendering and they show you where it is in the source code. They don't actually tell you anything about the MDP formulation or the reward or state space, whatever.
Right, right, right. Yeah, the like I feel like so my research area is not with continuous action space. That's why I don't really care that much about the reward definition. But otherwise, I would have. It would be very important to me.
Yeah, fair enough. So you only work with discrete action spaces mostly?
Yeah, I'm working with micro RTS. It's like a minimized version of StarCraft 2. So yeah, for the most part, it's
Okay,
discrete action spaces.
cool.
What about you? What are you working on?
Uh, yeah, I work on both usually, but I've only recently moved into RL from NLP, so
Mm-hmm.
um, it's kind of right now experimentation phases.
I see. I see. Well, that's great. That's great. Yeah. So this week, we're just yeah. By the way, the meeting is already recorded. I started recording once you started talking about the PY bullet because I think that's kind of a interesting discussion. Um, but yeah, this week for the most part, we're trying to integrate the branch that Rosalind has made a pull request for. I was just doing reviews and something, trying to finalize the details, and there's something that we can discuss about in this meeting. Yeah, for one thing, I would like to get your guys' opinions actually. So this is actually a current bug. So in the pull request, Roslyn used this sort of parser dot add argument dash dash kl action store true. Like its meaning wasn't exactly obvious to me, but after I look more into it, it makes more sense. And by the way, the objective is not to minimize the number of keystrokes, but rather like the current one that we have, like CUDA default equal to true, that wouldn't work. So if I want to specify CUDA equal to false using command line argument, it wouldn't work. So an example would be like here, where the person is saying my program dash dash my boolean flag false, then it would still output true, right? Sadly, it would still evaluate to true. So that leaves us with not a lot of choices, but to kind of do in this way, which is to just say by using the store true, and then so essentially we need to set a particular variable and have a default value. In this case, the dash dash kl, the default will be false, and then we say store true. But for things like that, for things that we want to set default to true, it would be like dash dash no CUDA and then store false. I don't know if that makes sense.
Uh, Another alternative will be to instead use dash dash CPU, so the CUDA will always be true by default.
Oh, I see, I see. Well, that's basically the same as dash dash no CUDA, right? With
Yes.
CPU, I see, I see. I mean, it would also work, but I think maybe no CUDA is more straightforward. That you know that you're not using CUDA, I guess.
Makes sense.
Yeah. And I was looking through this post. It's actually kind of interesting. So there are two things that I look for. The first thing is that can I directly modify the arguments in the file? So what that means is, uh, sorry, in the interactive shell. So for example, if I modify this to be false, can I still run it? And with the current approach that I have right now, it's very easy to do that. So I just save it and run, and then I can say args.torch deterministic, it's false, and I can toggle it to be true. So that's something that I look for, but I also hope to be able to toggle this variable, of course, in the command line arguments. And it turns out if I do it this way, I wouldn't be able to set it to false. So that's why we need to change it. And the other possible way is kind of hacky, is to do something like this: dash dash my flag and choice is equal to true and false. But then you need to sort of set this up, set this condition for each of the variables. I don't know, which way do you guys think is probably better?
Is the issue that it gets parsed as a string? Why is it that when you add false but you don't have defaults, it
Yeah,
doesn't work?
I don't really know. I feel like it's more of a bug than feature, I guess. But I'll show you an example. So, for example, like if I say Python PPO continuous action dash dash CUDA, and then I say false, that doesn't look right. Okay, I'll just do it this way. So did you guys see? Here I set CUDA equal to false, but when I print it out, it's still true.
That's really
Yeah, exactly. Yeah.
I'm trying to see. I added a arc for rendering,
Uh-huh.
and that seems to modify correctly. So
Could you show me? So if you
yeah,
set the defaults to be false, and then when you toggle it in the command line and set dash dash CUDA equal to true, then it's gonna work correctly. But if you
okay.
set it to false specifically, then it's not gonna change.
Try with zero.
Try with 0. Okay, that's interesting. It still doesn't work. It's still true.
What about the stringified false?
Huh? So right, yeah. So if you set this to be false, and then you say true,
It works.
yeah, it works. And then if you don't do it, it's just fine. Although I think if we do like something like this, it's gonna be true again. And then if you delete it like without the thing, I don't think it's gonna run. So it's just a very weird behavior, I guess.
And somehow doing the logical end.
Yeah, it's somehow like whenever it receives it has to receive something, and then no matter what it receives, it will always set the thing to be true. So that's why I think Rosalind's method is that actually makes more sense. That way, we should set this like no CUDA. Yeah, I'm actually gonna try that now. Although I should probably try it out before this meeting to save us some time. But we'll give it a try. So
What I always do for let me see what you see.
Yeah, so what if I have something like this, right? So I think by default, this is gonna give me false, right? So if I just run it, yes, it's giving me false. And can I toggle it here? Actually, yeah. So this is one of the drawback with this method. I wouldn't be able to directly toggle it at the using the interactive shell. Even though if I set default equal to true, it's still showing false.
If you use store true, you do not set the default.
Right. But what if I want to toggle it in the command line without toggle it in the file so that I can run it in the interactive shell without?
I don't quite get what you're trying to do. When you say store true, the default becomes
false,
automatically false.
Right. So what if I want this? So what if I just want to run the file right now and click it such that this will be true?
Yes, you have to pass the toggle, like dash dash torch deterministic.
But then I would have to run it in the command line, right?
Yes.
Yeah, so that's the trade-off that I'm not particularly enjoying. Like with the old approach, I would be able to say like if this is true and I press run. Oh, sorry, this is CUDA. Right. So if I say this is true, I will be able to modify it on a command line, and it's still going to be true. And now I can toggle it here. So it's almost like I'm looking for two things. I'm looking for the toggleability in the interactive shell here, as well as the toggleability in the command line. But both options seem to be not. They lose one or the other.
There seems to be a conflict, indeed.
Yeah, that's a very frustrating thing, but in any case, yeah. So I think next week we'll try to fuse everything together, and put put everything in the cleaner out repository, and then we should also start thinking about what to implement next. Do you guys have any ideas?
Recently, I've taken an interest into distributional reinforcement learning,
Oh, really? Nice.
and since I never did DQN in PyTorch, I was thinking of doing it, then upgrading it to the distributional version.
Wait, sorry, say that again.
Once I do the DQN, simple DQN in PyTorch,
Uh huh.
then I'm thinking of upgrading it with the Rainbow tricks, and then switch to distributional DQN with the implicit quantile networks.
I
So
see.
that's one idea, but sounds quite
Quite
troublesome.
quite challenging. Yeah. Yeah. Let me think.
What about twin delayed DDPG?
Yeah, so for that, you actually need to implement the DDPG first. And then, so I was talking to someone who has implemented the TD3, and then he told me that it makes more sense to implement DDPG first, and then move on to what's it called, TD3.
I see. Actually, I've already done DDPG, and the last thing I want to try is a parameter noise perturbation.
Okay. Like, you already implemented DDPG in PyTorch, or what do you mean?
Yes, in PyTorch.
Um,
Actually, before we started PPO, I thought we were gonna do DDPG. So I
oh,
did
you
that.
just finished it, really?
The stability really isn't that good. So
I see. I see. I wonder
but
if
still,
some. Yeah, I wonder if some of our tricks would help. Like, for example, the KL divergence trick that seems to be quite universal.
DDPG, since it's not a stochastic policy, we I do not think we can use such things.
Okay. Okay. Never mind. Um.
If other normalization stuff, actually, I wanted to try it with soft actor critic too. I need to add it to the to-do list.
The KL divergence.
Not the diverse normalization, for example, observation and reward,
Oh, yeah,
especially the
yeah, yeah.
reward.
That would be a fun trick. And I just experimented with the KL divergence trick with the spinning up PyTorch library and prove, well, not exactly prove, but I have one instance of evidence that the KL divergence is actually crucial to their implementation as well. So if you see that, so this is with the max KL divergence trick, and you see the average episode returns is almost 2,000. While if I toggle it off, the average, well, actually, yeah, it blows up like R did. It goes to 95 before it reaches something much higher, like 1,000 or something. But it eventually blows up like ours did.
Yes, basically no KL is no learning
Yeah,
in
no,
this case.
yeah, that's very fascinating.
It's the PPO, right?
Uh, yes, this is the PPO.
Hello.
Hmm?
Okay.
Yeah. Yeah, so it turns out it is one of the most crucial techniques. But anyway, let me think.
A quick question while
Yes.
we're on the PPO.
Mm-hmm.
I see in your PPO batch you wait, should I bring up the code? Probably.
Yeah, I already pull it up here as well. Oh, not this one. Actually, yeah, it is this one. Yeah, go ahead.
I hope it's the most recent version. Uh, Here I see you use a mini batch.
Mm-hmm. Are you showing your screen right now?
Yes, is it showing?
Oh, yes, yes, yes. My bad. Okay, all good. Go ahead.
Uh, well, here I wonder why you use a mini batch
Hmm.
for each update.
Right. So first of all, that's what the. Let me see something real quick. Isn't that what the PPO? What does the spinning up do?
In spinning up, since PPO is a originally online learning method, once they have sampled an episode, they use the full trajectories.
Uh
So
huh.
no mini batch. They use everything that's in the small buffer because there's usually only 1000 transition anyway.
Okay. Let me
So
see something real quick. And it's also kind of interesting that mine still works, but let's take a look at something real quick. So,
it's and
so when you finish a batch, what does the finish batch does?
finish path. Is that
Finish path. Oh, sorry, finish path. So that. Um,
I think because they're using a buffer, the sampling process and the memory itself is separated. So
mm-hmm,
the advantages which needs to be computed at the end, well, it's
mm-hmm.
kind of hard to do it since we store everything in the buffer and the indices of the trajectories are like all together.
Right,
So
right.
once one episode is done, they use finish patch to go back to the first transition,
Uh huh.
compute everything like the return and advantages, and then store it.
Uh huh. Let me see your code real quick in a pull request because I remember you probably had something similar. Yeah. Uh,
To not use finish path or whatever, I have a temporary wait, where is it? I have a kind of a temporary buffer for each episode.
uh huh. Hold on one second. So, in the code that you pull request, did you see your sampling from the buffer?
Wait a second. Uh,
It's
where
also
is the file?
it's also interesting you're sampling the entire size. But let me see something real quick. Are you,
Because it's only 1000 transition anyways.
uh-huh. Right? But in the replay buffer sample method, did you see the mini batch? Oh, never mind. You're sampling the entire thing, right?
Yes, the size is still 1000. So.
Right, right, right. I see.
But the remark here is that when using mini batch, there's actually the policy learns less than it could in one epoch iteration. I mean, one update iteration.
The policy learns what?
Learns less than it could.
Yes, yes, of course.
So I don't know how well does the PPO batch fare. Do you have any
Yeah,
YVD reports
yeah.
you could pull
Well, not for too much, but let's take a look. So let me see. So that will be here. CD experiments and TensorBoard log dir runs, and let's go to localhost 6006. Yeah. So this is the. Whoa! What is this? Oh, I see. I see. Scratch that. Right. So this is the performance of the PPO batch. Um,
Both are PPO batch, right?
right. So the first one, the green line, it's only updating for one epoch. So every time it samples, it only updates for um, what's it called? One epochs. So that's in here. Like for range in arcs update epochs, it only updates one epochs. So that's
One
why,
time.
huh?
Okay.
Yeah, so that's why it's learning so slow. But then later I tune it up. I think the latest version, the update epoch is like 50, which is why it's performing better.
Better. And which environment is that Hopper, right?
Yeah, it's Hopper Env. I was wondering what's the performance on just a regular, the ones that we used before.
It's around 2000 if
Oh.
you with the KL bounding.
What if without KL bounding? Because this is without for KL
I
bounding.
think it's around 1000, 1500.
Okay, well then it's fairly similar then.
Yes.
Let me see something real quick. Okay, okay. Right. So we can experiment this, and one other thing that I would say about the particular choice. By the way, um, I really thought somewhere it's probably this guy's repo or let me see something real quick. Give me 1 second.
No problem.
So does he do sample? Let me see. Yeah. Uh, yeah. So this is why implementation is messy. I've seen cases where also people do something like exactly the way that I've done it, which is you sample a mini batch, and let me see how large is his mini batch. So in this case, I kind of copied this code from him, but I think it's cleaner than he is because he has a buffer for what no reason.
Hmm.
Well, that's in general how I feels anyway. With a bunch of implementations, just have a buffer for no reason. Like you don't need the buffer. But I would say that the reason I would argue there's an advantage for keeping this sort of random index instead of just updating across the entire trajectory, which I also think there are advantages of that. Like I don't know if you remember, but 2 weeks ago I sort of talked about the issues that I was having in my own research, where the KL divergence would actually blow up. Let me see. So, are you guys able to see this?
Yes.
So this is updating the trajectory for each episode has like 2,000 time steps, and at some point the KL divergence just kind of blows up, and then as you can see, the KL divergence is about 0.1244, and I think by using the usual KL divergence cutoff, the cutoff threshold is something like 0.015. So this means the agent never learns after here. So that's why the performance after here it just kind of stays constant, even though it's keep running for a long time. And maybe I was wrong, but maybe I would be wrong. But I was wondering if I, instead of optimizing over the entire episode, if I just pick like just some indexes of the entire trajectory to optimize. I figured the KL divergence probably wouldn't be this much.
But I'm not sure about that because in the end, the KL divergence, you take the mean, right?
Yes.
So no matter how many transition you feed into the network, if the KL, well, if the policy are similar, the KL divergence should still be around the same on average.
Hmm. Yeah, that is the problem, and yeah, I really don't know. That's a good point. So why? This really should be my own problem, but do you have any idea of why the KL divergence would blow up like this?
Honestly, not much. It's a micro RTS, right?
Yeah, yeah, that's the environment that I've been working on. And another thing that I think we should start doing is also just to log the KL divergence when we do the PPO thing. I was just kind of curious because you logged how many time steps before the how many iteration of update before the KL divergence cutoff, right? But you don't actually
Yes,
see the level of KL divergence at each time step.
good point. But okay, still, it's still expected to be under the like maximal target chaos.
Yes, I
Okay,
think so. Yeah, that would be. I think that would be an interesting thing to look at. Just in
yes,
general, though, I think there are very different ways for you to do the steps. Like if you look at the
yes.
baselines library, they also do things very differently. So in a way, the whatever is in the baseline library is actually in a way more similar to the sort of random mini batches that I was doing right there. So if you go to PPO2, and then if you go to PPO2.py, here you're gonna find this parameter, which is not very well documented. It's called num steps or step n
Does it
step.
goes down step and steps?
Okay, let's see. Like here, the n step is very large, but but in something like A2C where you see the n step, uh, right. Here you see in A2C the n step is 5, which is something that is very small. And when you see the actual learning part, okay, this is probably not the, again, like the repo is always so difficult to read. But in this guy's repo, it's also very famous, and his ways of doing update is also very interesting. And he has this parameter of num steps as well. Let me see. Right. And the way he would do it is to run the environment for a fixed number of time steps and then calculate the returns. And then basically do the updates, right? Yeah, agent update the rollouts. And then if you look at the default number of time steps, which is at here, where is it?
This is such a mess.
Yeah, tell me about it. Yeah, you see the default number of time steps is 5. So that would mean the A2C ran the game for 5 time steps and then optimize the gradient over that, and then run the time steps for another 5 time steps and then optimize
Mm.
over that. You see where I'm
I
going with
see.
this?
It's a trade-off between online and offline learning, right?
No, not really. So I was actually doing a presentation on this to my advisor. So incomplete ideas. Let's take a look. Let's take the reference from the Sutton and Barrows book.
AKA the Bible.
Yeah, kind of right. So if you take a look at here and reinforce with baseline, and also they do things very differently too. That's why it's kind of interesting. Here, look at how for each step in the episode, they update a gradient for the value function as well as for the policy.
Every step.
Yes, every step. So in the traditional ways that we have done it, it's more like uh, we run the episodes and then we calculate the W and the theta at the end of the episode for each of the time step and then update. So
Mm-hmm.
the particular way that they are doing it, which by the way, their performance, like their empirical performance is pretty good. I've experimented with it, but anyway, what essentially they're doing is for each 5 steps, do this, right? And the way that the mini batch sort of does is to say, find a random t such and do this, right?
Okay, so when they do the gradient updates every 5 steps, for example, they use the mini batch, right?
That will be essentially a mini batch. So it wouldn't be a random mini batch, but it will be a mini batch of every 5 steps. Yes.
I see.
That's very interesting, right? It's like, why? It's not that difficult. Why do you do it so differently? And they all yield comparable results somehow.
My intuition here would be that, well, since we do updates every 5 steps, and an episode could take, for example, 1,000 steps, the policy changes while learning, right? So it's basically online learning.
Mm-hmm.
Instead of waiting for all the episodes to end, then update, then run the policy again. So beside of that, I do not see actually uh, another effect.
Right, right.
Going back to the online part, since we do more updates while the agent is learning, we will not, for example, waste time if, let's say, at the 100 steps out of the 1,000 of the whole episode, since we already update at the 100 step, the 900 step will be used for something more productive instead of just using an old and suboptimal policy.
Right,
But
right, right.
besides that, I do not see really any change.
I see. By the way, for the on policy and off policy, I don't think this is where the distinction is drawn. So, off policy is saying,
No, it's online. I meant online versus offline.
right, right. Is that what is the difference between online and offline methods? I kind of forgot.
Offline, we wait once everything is sampled and we do the updates.
Uh huh.
And online, contrary. But on policy concerns the trajectory that are used to update the policy.
Right, right, right.
Policy, we can, for example, use a uniformly sampled data to
Mm-hmm.
update the policy. But on policy, we use the data sample following the same policy.
Yes, yes.
Kind of a tricky point, actually.
Yes, I was too focused on the on policy and off policy and just kind of lost the distinction between the online and offline.
The main advantage, I would say, is to gain in sample efficiency.
Mm-hmm. Right. Yes. So that you don't have to walk through the entire episode to
Yes.
do something. Right. Okay, that makes sense. Yeah. Okay. I think either way would work. So if we were to use the old way, but again, would you agree that the buffer is really not the
It's irrelevant in a PPO. I do agree.
Yeah, it's irrelevant in PPO. It's just like noise. Like, why are you there? you know.
Yeah, but
So I.
in contrast,
Mhm.
if even when using the like temporary storage, the index manipulation is kind of not really tasty.
Do you have a pointer? Like, which specific part are you talking about?
Wait, I bring back the PPO badge.
Yeah.
Well, while at the beginning it's quite easy to understand, we have like
Oh, you're talking about the random sampling of the batch, right?
not the random sampling, but managing the trajectories itself.
Okay.
Up to here, I think it's okay.
Uh
But
huh.
once we come in the, for example, return computation,
Uh huh.
we have all these indices that are
Oh, I see.
manipulated. Episode length -1 +1.
Mm-hmm.
Uh, uh,
Yeah. It gets harder to understand, right?
okay, I think I got it now, but it was after. I see.
Right, right, right. That's basically saying
Yes.
the last episode, like index up until
And
the yeah, it's
it's
indexing.
basically asking where did the episode we are trying to compute the return started,
Hmm.
or something like. Okay.
Right, right. So you're absolutely right. Like that is not the best way to write that. But the other thing that I sort of want to point out is that since we're running it like this way, like again, one of the main advantage of using something, using a structure like this is when we have things we don't understand. Like I could just pause the program and just say, okay, I want to see the episode length, right?
Uh-huh.
And I can see exactly what's going on, and then I can see this. What is this? It's very easy to debug. I can just see what's going on.
Fair enough.
Oh, I see. I need to just. Yeah, you get what I mean.
Yeah, yeah, sure. It's each method has its pros and cons. So. But in this case, we should stick probably to your method here.
Yeah, either yeah. So I would say probably in that case, then we probably shouldn't do the mini batch. So it depends, right? If like whether we want to do it more like the baseline style or the spinning up style. Actually, in the baselines, when they do the number of steps, do they just update it or do they sort of do it afterwards?
I have no idea. Baselines, right?
Yeah. So do they after the five steps, let's say, do they just update the model or do they sort of wait until the episode finish and then update every five intervals, every five
No,
steps?
I think they update while the episode is running.
Okay. Okay. That's fair enough. Okay. Right. It's just a different ways. Yeah, okay. In that case, I would just say probably don't worry about what I have right here, but rather just take the entire index, right? So
Yes.
that would be instead of doing the random choice, I'll make a modification to this, but instead of this, it'll be just all the index from the observation from zero to finish.
Sounds good.
Yeah, sounds good. Sounds good. What else?
I actually had one more question regarding the return normalization, not rewards.
Okay, go ahead.
I well, shamelessly copy pasted your PPO return norm reset,
Not a problem. Not a problem, man.
and well, I tried it on virus environment, and aside of let's say half cheetah,
Oh, Costas return. Normally, okay. Let me see. Well, so what's going on over here?
aside of half cheetah, actually the none of the agent is learning.
Yeah,
Unfortunately.
that's kind of a
But
weird thing.
if I remember, oh wait, it's if I remember correctly, on your side, it's actually learning something at least.
Okay. Not all of it. Some part of it. Let's take a look. I think it's the. Wait, this is not mine, right?
Yes, it's yours.
Oh,
I
okay.
just copied the report. This one is Walker,
Uh huh.
and let's say it has a running reset is true.
Okay.
Well, but best case scenario, it reaches something around 100.
Uh huh.
But here, I
It's
am
nothing.
pretty sure, yes, it does not reach.
Did you use the same seed? I mean, that probably doesn't matter. But did you check if the files are actually the same?
Yes, there might be a difference because it was last week I tried it, but yours might be older.
Right, right, right. That could be the problem. But did you so in your version did you try with the KL divergence bound?
Yes, with both.
Okay, so that might be one of the larger difference then, because in my versions the KL divergence bound was not there.
You mean this one, the PPO return norm?
Yeah, so the current page that you're showing me right now.
Yes, there is
Uh,
no KL.
okay, okay, then it's correct. Okay.
When I try with my own implementation
Uh huh.
with and without KL, actually. Okay, so I think here is without the KL,
Uh huh.
and the one in Murasaki, how you say this, purple, yes, is the one using return norms,
Uh huh.
but no much learning done here.
Uh huh.
So I'm still not convinced in the computation of the return normalized return.
Uh huh. Uh huh.
I was wondering if you had much more success than me.
Oh, probably not. Yeah, this week, yeah, I was working on our research project. I was
Oh, okay.
prioritizing my time mostly on that, and for the kind of following weeks as well, because it's kind of a shitty situation. Um,
The valley of shit.
yeah, yeah. I mean, it's not a. Uh, I don't know. I don't feel the particular project we're working on is that interesting. It feels more
I
of
see.
a.
How about does resetting the rewards and observation filter really matters?
But in one of your experiments with the KL bound, you did show the either reward normalization or return normalization matters, right? If I remember correctly.
There was indeed something like that. Well, the observation was that with the KL, we have that it's more stable.
Uh huh.
I have no idea where this one is. Let's check it out real quick.
Yeah. Yeah, it's
Well,
so funny. Most of the most of the without the KL bounded situations.
at the end, it really breaks down, degenerates.
Yeah, exactly. It's look like the exact same results with the in the OpenAI spinning up. Without the KL bound, it just it's pretty good. But with the KL bound, sorry, without the KL bound, it's pretty bad. But with the KL bound, it's exactly the same thing.
Yes, I would say the trust region is not respected, so that's why.
Yeah, so their tricks, it's like it doesn't really matter. It's really
Okay.
just the KL bound trick that's one of the. So all the other tricks are contingent upon the KL bounded trick.
Mhm.
Seems to be the case. But anyway, go ahead.
No, I think I'm quite done actually.
Okay. Wait. So in this case, are you doing the reward normalization or return normalization?
This one is the simple reward normalization,
So the Z filter.
Z filter. Yes.
Okay. So the unnormalized version is actually performing better.
No. The The normalized version is better.
Oh,
Wait,
sorry. You know what? I was looking at the wrong thing. It's a no KL that I was looking at. Okay, okay.
wait. When we normalize the reward, it's actually there's quite a significant performance improvement.
Yes, for sure. That's interesting. Yeah. Okay. So let me think. What's gonna be for our next step?
Yes.
Um,
Next.
yeah. So I want to sort of take things slowly because just a lot of things is going on. So I would say next week we'll try to finish everything up. Try to integrate everything, and then again run the benchmark using. Oh, by the way, there's something that I want to ask you guys' opinion. So this report, it's sort of getting too bloated. Too many videos and too many runs. Do you guys think we should try to separate it, like a continuous report, a benchmark with continuous domains, benchmark with discrete action domains? Do you think we should try to do that to avoid having too many runs on the same page?
Makes sense to me. I was also doing my experiments under discrete and continuous action spaces.
Mm-hmm. What about you, Rosalind? Do you feel the same or?
I do not really have much opinion. I will say it for me it does not really matter either it's if the state is continuous or discrete, but concerning the method, especially in the PPO with all the thousand tricks,
Right.
I found it useful to separate first,
Mm-hmm.
following the algorithm like SAG, PPO, then do all the experiment, and then have a common report to compare all the methods once we have selected like the representative.
Say the last part again. Sorry.
Hmm?
Could you say
So
the?
once we find the good a good representative for each algorithm, then we could like make them fight in the general clean RL benchmark
Okay.
report.
I see. Okay, I gotcha. Okay, I'll think about what may be the best solution with this. Also, I'll consider about what's the best solution for the sort of Boolean argument toggling. I really wanted to do both, being able to be toggled in the interactive shell as well as in the command line argument. So those will be the two things that I'll look after, and so for the project monthly development cycle for the next month, I think we started this discussion. So what about we sort of do the DDPG and then work our way up to the TD3?
I agree.
Okay. Yeah, because other than that, and I think after that, after the TD3, we would have reproduced all of the state of the art reinforcement learning algorithms, the model free ones, and then we can start it branching out and trying out different things. Like a couple other things that I think will be really interested to experiment is the distributional reinforcement learning, sort of like the what Rosalind mentioned. And the other one is a lot of the what's it called? It's like huh?
Model based, maybe.
Yeah, a little bit model based, but also the one that I was thinking of is actually like curiosity driven learning. It's like intrinsic rewards.
Hmm.
Yeah, I think after so the DDPG and TD3, those will be like some of the more fundamental algorithms. I think it would be good if we try to just have the major reinforcement learning algorithms sort of in the back, and then we can branch out to some of the more unorthodox, maybe not unorthodox, but some of the more creative methods. Right.
Sure, no problem.
Let me see what kind of algorithm does Sable Baseline have, because right now we've covered a bunch already.
They also have imitation learning.
Really?
Yes, they have Gale is basically imitation. So
Oh, okay. I'm not sure. So let's take a look. So I'm not sure if we will be interested in implementing actor.
actor is basically parallelization of A to C, if I'm not mistaken.
Yeah, that's not very interesting. Uh,
Acer, what was Acer?
Laptops. So that seems to be sample efficient actor critic with experience replay. I don't know. Those seems to be variants of A2C, which are interesting, but I feel like trying out something like DDPG or TD3. Those are more different directions, but also the more major directions as well. Yeah, and we have already implemented SAC, and then once we get the DDPG and TD3, we would have incorporated all of the major reinforcement learning algorithms. TRPL, I would say, probably not, or yeah, because it seems to be an old algorithm. Like even with the tricks, it's just sort of comparable with the PPO, and it seems to be a fairly complex one to implement, apparently.
According to the paper, they said that TRPO plus implementation tricks actually wins the battle.
Well, but they only I saw that, but they only ran it for like 3 environments, and TRPO plus one like one or two, right? Sorry, two, right? Something like that.
Yes. Wait. I think they called it TRPO plus, right?
Yeah, because that for me it will be sort of saying it's just comparable to or only a little bit better than PPO, which is I don't know. I don't feel like it's gonna worth the effort to look at something.
I say it has quite a large margin, at least in three environments.
Really, let me see.
Weimer, Hopper, and Walker 2D. It's something around 20-30% performance improvement over simple PPO.
Okay. Um, let's see. Yeah, I mean, we can definitely implement it in the future, but I would say we should probably treat it like a low priority.
Okay, no problem.
Yeah. What about you, Ali? Do you have any algorithms in mind that you be interested in implementing?
Yeah, I would love to see the rainbow implementations, all the 9 tricks from distributional RL to the dueling DQN and so on.
Uh-huh.
I think that could be fun.
What is
Uh,
rainbow, by the way? I remember they say the fuse tricks. What does that even mean?
Fuse, just combined.
Like, how do they combine? It seems such an arbitrary term.
Do you mean fuse in the PR request
No, no, no,
with
no,
the
no, no, no. Like, what is rainbow? Like, it says it combines all
uh,
of the advantages. I'm not
I
sure.
think they're trying to be cute about it because they draw learning curves with different colors, so it looks like a rainbow.
Yeah, but
But I think fusing just means similar to how Dawson and you have combined all the PPO tricks from the Marjorie paper into one implementation. It's the same thing.
like, do they mean they just have like a double Q function, prioritize experience replay,
Yes, yes,
and
yes.
dueling and distribution, and basically combining all of the arguments somehow?
That's crazy.
Yeah, I don't know. I feel like that would be, yeah, we could definitely work on that. And I feel
That's
like,
a lot of work.
yeah, it's a lot of work, but I feel like